Hello, everybody. Welcome back. I am very excited here today because today we're talking about red light therapy for skin rejuvenation. And I once again have my friend Bev Sanderson, who is not just a dear friend of mine, but also a science graduate and the founder of Maysama Skincare. Now, Bev, I wanted to have you on because with your knowledge of cell biology and your passion for red light therapy, I know that you will be able to help us understand the use of red light therapy for skin rejuvenation a lot better than we do at this point. So thank you so much for being on, Bev.
Thank you so much for having me back.
I'm very glad you're here. So, Bev, many of my viewers already use red light therapy, but for those not familiar with it or even skeptical of red light therapy, can you tell us what red light therapy is and how we can benefit from it?
Yes, sure. So red light therapy, also known as photobiomodulation, is the use of red light or near infrared light to stimulate biological processes. I think in the skincare community, we're most familiar with it for anti-aging, but red light therapy is much broader than that in terms of its applications. So we'll find athletes using it, for example, for enhancing performance, and it's also used in the medical profession for wound healing and also for management and treatment of various diseases, albeit experimentally at this stage. I think for some people, red light therapy is a little bit out there, but when you consider that plants use light energy to photosynthesize, it's not really irrational to consider that animal cells can also use light energy to improve our health. And red light and near infrared light's different to any other wavelength in that it penetrates the skin. So if you look at visible light, if you were to hold a red light up and put your finger in front of it, you'd find that your finger would illuminate because the red light penetrates the skin. And you wouldn't see this with green light or blue light, for example. Not to say that the other wavelengths, the visible wavelengths, are not also useful to the skin. They also can treat the surface of the skin, but it's the red light that can penetrate the skin. And it can penetrate skin, brain and brain tissue and also bone, so up to 2 to 3 centimeters. So the literature suggests that red and near infrared light are part of nature's natural defense against UV light. So you have a high amount of near infrared light early in the morning and then later again in the afternoon, and it can offer a preparative and reparative effect against UV light, which is very interesting.
That is very interesting. Can you tell us exactly how red light therapy works in terms of biological response?
Sure. Well, red light therapy increases cellular energy. So our mitochondria are the main source for light absorption. Mitochondria are just organelles found in every living cell, and they're responsible for producing ATP, or adenosine triphosphate, which is the energy molecule in cells. So both red light and infrared light are absorbed in the mitochondria, and they're absorbed by a key enzyme called cytochrome C oxidase. Now, this enzyme is really important because its key function is to bind with oxygen. But there's another little molecule that also binds with cytochrome C oxidase, which is called nitric oxide. And if that happens, it stops this key enzyme from reacting with oxygen, and so it stops the production of ATP. So this is where the red light comes in. Red light penetrates the mitochondrial membrane, and it releases nitric oxide from cytochrome C oxidase and allows it then to bind with oxygen and then carry on that mitochondrial respiration and produce the ATP. So that's a really well accepted theory for red light therapy, but it might only be part of the puzzle, because red light therapy just creates a whole cascade of events. So it reduces key proteins that are associated with age decline. It reduces oxidative stress, it increases cell survival rates, it increases cell migration and cell proliferation. So there's so much more. But there's another theory as well, which I absolutely love, which is to do with structured water. So that's a little bit more intriguing.
Wow, that is really interesting and intriguing. Will you tell us a little bit more about that?
Sure. Well, our bodies are made up of 90% of water. We know water to exist in 3 phases. We know water, we know ice, and we know steam. But there's evidence of a 4th phase of water called structured water, or even sticky water, or easy water we sometimes hear. And this phase of water exists when water is near to a hydrophilic membrane. So the mitochondrial membrane is a hydrophilic membrane. It just means to attract water. And when the water near to hydrophilic membrane has a high level of free radicals in it, then the water becomes sticky. So why is that important? Well, the last enzyme in the mitochondrial respiratory chain is called ATP synthase, and that is like a little tiny motor that makes ATP. Now, if you imagine a motor working in water, it's fine, but if you imagine a motor working in treacle, there's a lot more resistance, so the production of ATP slows down, and this is where red light comes in. So red light therapy, the red light penetrates the mitochondrial membrane and it releases the free radicals. And releasing the free radicals then reduces the viscosity of the structured water and allows the tiny nanomotor to speed up, increasing the production of ATP. So this structured water could be the key to how red light therapy works.
So this is why I wanted to have you on, Bev, because your knowledge is just incredible. I am learning so much.
Thank you.
And you recently wrote a blog on the influence of red light as well as infrared light on anti-aging and skin rejuvenation. I know we all want to hear more about that. So can you elaborate on that?
Yes. Well, I think there's some debate, isn't there, about which is better for anti-aging, red light or infrared light, or use both together. So I was really interested to sort of research the literature and see what was out there regarding this. And interestingly, there's a paper written by the University of Florence in Italy, so not so far from you, actually.
Yeah.
Shed some light on it. Forgive the pun. Anyway, so yeah, that one actually relates to wound healing, but I think you can relate it to anti-aging because it talks about the different influence of red light and near infrared on collagen production. So the paper, the study shows that red light increases the production of MMPs, which are matrix metalloproteinases. They're basically proteins found in the extracellular matrix. And when you increase these MMPs, that increases cell proliferation. So the fibroblasts, which are the main cells in the connective tissue, then increase. So they grow and they reproduce. So that's the first thing with red light. But infrared light has a different effect. It doesn't increase the proliferation of cells. It actually allows those cells to mature into, well, to differentiate into more mature cells called myofibroblasts. So it decreases the MMPs, which stops the proliferation, and then allows these cells to mature into their more mature form. And they secrete type 1 and type 3 collagen. So certainly the literature would suggest that using them together would be beneficial. They don't happen, it's not like one step and then two step. You can kind of, using the two together will make that happen.
So that is certainly encouraging. I have heard some people talk about near infrared light therapy increasing the melasma, versus others have said that near infrared is actually dangerous. What are your thoughts on that?
Yes, I'm aware of that feedback, and I think there's certainly some inconsistencies with the studies on near infrared light. I think the pigment increasing issue is probably more related to heat generated by the near infrared devices that are used, because we're aware from the studies that a very small increase in temperature can increase pigmentation. So that probably relates more to that than the wavelength itself. So I think, if you are somebody that suffers with melasma, maybe steer away from near infrared if you want to be absolutely safe, because you could always use blue light instead. Blue light has many of the same effects as near infrared, but without that risk of heat generation and potentially melasma causing. So that's always an alternative. I think the other data which talked about skin wrinkling with near infrared, it related to a very high fluence of near infrared, and it's not really relative to the devices that we're using typically at home. So I'm not personally overly concerned about that. There's a paper written actually called Infrared and Skin, Friend or Foe, and that certainly supports that near infrared is far more beneficial than it would be harmful. Okay. And it talks about near infrared possibly even being preconditioning and protecting us against UV light. So that's very interesting. There's lots of in vitro studies that have used fibroblasts and they've been preconditioned with near infrared, and then that's reduced UV damage further down the line. And that's called photo prevention. So that's quite an interesting phenomenon as well.
That is interesting. Now, let me ask you really quickly, somebody with melasma could still use just regular red light, right? Instead of infrared. Okay.
Yeah, yes,
without
but combining red and near infrared, they might want to combine red and blue.
Okay, that is good to know. So Bev, as red light therapy is becoming more popular and many of us are investing in home devices, LED masks, lamps, panels, many of us think more is better, myself included. Can you overdo LED light therapy?
That is such a great question. I think it's really tempting, isn't it? You know, when something is good for you, to assume that, you know, you want more of it or to have lots of it. But that's not always the case. Sometimes less is more. There's a phenomenon called the biphasic dose response. It's also called hormesis. And it talks about when you have a stimulus, that initially that stimulus can trigger a biological response. And then if you have more of that stimulus, that can increase response. But then at some point, a peak is reached. And if you continue increasing that stimulus, then it starts to suppress the biological response and eventually gives you a negative response. And we see this a lot in red light therapy. There's lots of evidence that talks about it. And it generally shows that a lower level of stimulus is better for creating a biological response. So I think it's one of the reasons actually why red light therapy has not really been adopted within, you know, mainstream medicine, because it's really difficult to get that consistency. Whilst there's lots of data around this biphasic dose response, nobody can really agree on what the optimum, you know, parameters are for dosage and treatment time, etc. But it exists, so it's good to know that sometimes less is more.
So that is really good to know. So how do we know 10 minutes, 20 minutes? How do we know how long to use it for?
Well, it will depend on the device. So that's really where you need to refer to the manufacturer and the device that you're using. So they will give you the best recommendations for that particular device.
That's good to know. So Beth, there's been a lot of discussion on combining red light therapy with green tea for better results. What are your thoughts on that?
Well, green tea is a powerful antioxidant. We know that antioxidants scavenge free radicals and red light produces free radicals. So it makes sense that combining them, you know, they've got this complementary action. So red light, we hear generally that red light produces free radicals as a byproduct, but if you subscribe to our sticky water theory, then you'll understand that the free radicals are far more than a byproduct. They're an integral part of how red light therapy works. But when those free radicals are released from the mitochondrial membrane, where do they go? Well, they go into the cell and they accumulate inside the cell. And if we get an excess of free radicals, if those build up inside the cell, then that creates a condition of oxidative stress. And oxidative stress, if that carries on, that will lead to cell damage to lipids, damage to proteins, and damage to DNA within the cell. And ultimately, if there's too much damage, then the cell actually kills itself by a program of cell death, and that's called apoptosis. So we want to prevent that, and that's where the antioxidants come in. So antioxidants will scavenge those free radicals, mop up those free radicals. And if that happens, then it allows your red light to carry on producing more ATP and get a better result.
So why green tea? Could we use other antioxidants as well? And is there any supporting evidence?
Well, green tea is particularly relevant because it's known to scavenge free radicals near the mitochondrial membrane. So that's why it's particularly relevant. But yes, there's evidence of other antioxidants working with red light therapy as well. There's other studies. So there's a study on guarana, for example. Using guarana with red light therapy actually reduced the incidence of cell death. And that's as a result really of reduced oxidative damage from free radicals. And it also increased cell proliferation. Then there's another study about resveratrol, combining resveratrol with red light therapy. That one's actually in relation to wound healing, but it's still relevant. So with wound healing, what we want really is to prevent scar tissue. And if you use red light therapy, it produces an excess of free radicals potentially. and that slows down cell proliferation. And if you slow down the cell proliferation, then that stops the cells migrating to the wound and depositing collagen, so you don't get the scar. So that's how that works. And in this study, they then introduced resveratrol, and that actually interfered with the efficacy of the red light. So again, it's kind of, it's different information, but they both support that antioxidants have this buffering effect for free radicals produced by red light therapy.
Many of us are aware of a study done by a NASA scientist on green tea combined with LED light therapy. However, the study is quite small. Is it valid at all?
Well, I think we have to remember that red light therapy is an unregulated field. Even the scientists get conflicting results, which is one of the reasons that it's not been adopted by mainstream medicine. But there's over 5,000 papers written on red light therapy, and a lot of them in relation to antioxidants and red light therapy working together. So yes, every study is valid. They all give us new insights into how antioxidants and red light therapy work together. But it's not the only paper that the NASA scientists wrote about green tea and red light therapy as a combined therapy. They actually designed a model for Alzheimer's using red light therapy and green tea. So if we look at Alzheimer's, it's associated with a deposit of protein fibers in the brain called amyloid fibrils. And in one study, they found that green tea actually decreased these amyloid fibrils. And then another study, they found that red light therapy also decreased these amyloid fibrils, but combining them, which is what the NASA scientists did, then decreased the deposits even further. So it shows that they work together as a complementary therapy. But there was lots of things within that study itself that were interesting. The author Sommer describes that the red light therapy increases the uptake of green tea actives. So another good reason for combining antioxidants with red light therapy. And he also states very clearly that the results that they see are not restricted to red light therapy with green tea polyphenols, but that other antioxidants would work in a similar way. And then finally, that it's a complementary therapy. Sorry, a combination therapy. So what they mean by that is that the two components have complementary actions. So you've got the red light therapy producing free radicals, the antioxidants scavenging free radicals, and because they're complementary actions, they work very well as a combined therapy.
So you mentioned the scientists stating that the complementary benefits of antioxidants and red light therapy is not limited to green tea polyphenols. So could we use any antioxidant?
Well, the science certainly suggests that in general you could use any antioxidant, but I'm going to be as bold as to say that some antioxidants will work better than others. So green tea, for example, is known for targeting the free radicals produced by mitochondria. So it's known for targeting the mitochondrial ROS, reactive oxygen species. So that's what makes it particularly good with red light therapy. Guarana and green Rooibos tea have a very similar profile to green tea. And as you know, we did an independent study, a collaboration with the Nelson Mandela Institute, and we looked at our pharmaceutical grade green Rooibos extract in relation to other antioxidants and how it performed. And they all have, slightly different results. So some perform very well outside the cell and others perform well inside the cell. And our green Rooibos was, in terms of its antioxidant potential, it was comparable to green tea, and it was active to the same degree inside the cell. So it was bioactive to the same degree. But more than that, both green tea and green Rooibos tea work in harmony with the cell. And what I mean by that is that the cell has its own antioxidant defense mechanisms that exist just naturally within the cell. And green tea and green Rooibos, they stimulate those intrinsic antioxidant defenses that the cell has. So it works in harmony with the cell. And we didn't see that with other antioxidants like vitamin C and resveratrol, for example. So it certainly suggests that green tea, green Rooibos tea, guarana are excellent choices for use with red light therapy.
So could you just brew a cup of tea, green or Rooibos, and apply that to your skin and combine that with your red light therapy?
Well, you could do, but if you're looking for high performance, then I'm pretty confident that a cosmetic serum or toner will serve you better. really because, if you look at teas, they're sold on the basis of flavour. You take a cosmetic ingredient and it's sold on the basis of performance. So a green tea ingredient, for example, that we might buy in, you buy it on the basis of its antioxidant potential, which is not the case with a tea product. So if you take our green Rooibos extract, for example, it's a phytopharmaceutical. It's 70 times more potent than organic Rooibos as a raw ingredient, which is why it costs about 100 times as much to produce. There we go. And also, serums improve the absorption of those active ingredients as well. Not just Maysama, but any serum out there. But I know, for example, in Maysama we use tetrahydropiperone, which helps the absorption of the other active ingredients, helps them to get into skin. We're formulating a new serum at the moment, and my chemist said to me, "Do you want to include the tetrahydropiperone because it's very expensive?" I'm like, "Yes, of course I do. It's a serum." That's why people buy serums, because they're high performance. That's the whole point of it. But more than that, it's the increased purity, it's the increased stability that you get with cosmetics as well, toners or serums. So there's other products out there that will work in that regard. And obviously I know my serum, so I'm going to talk about my serum in particular. But if you look at how red light therapy works, if the skin is hydrated, then the light penetrates better. And with Maysama, it's absolutely loaded with humectants. You've got aloe vera in there, you've got sodium hyaluronate, you've got glycerin. So that helps the light penetration.
So perfect. So if somebody is using green tea or antioxidants with their red light therapy, what would the protocol be like?
Well, in the original paper written by the NASA scientists, they talked about putting cotton pads on the face soaked in green tea and leaving that for 20 minutes. So I think that's kind of where the protocol has come from, that people are talking about applying green tea 20 minutes before red light therapy. And really, you just need to allow time for whatever you're using, whether it be tea, whether it be a toner, whether it be a serum, to soak into the skin. Now, we've talked about the fact that serums generally absorb, they have ingredients within them that can help the absorption of ingredients. So it could possibly be slightly quicker, but you still need to allow time. So 15 to 20 minutes before you do red light therapy, apply your antioxidants in whichever way you prefer to apply them. And then do your red light therapy for whatever time the manufacturer recommends. And then after that, continue with the rest of your skincare regime. You don't need to wash off your antioxidants before or after your red light therapy.
So we know that green tea or other antioxidants work great in combination with red light therapy, but are there any ingredients or formulations we want to avoid in combination with red light therapy?
It's a good question, actually. There is evidence around oils having an effect on the light penetration, so they do recommend that we avoid oils in formulation. So if you've got a gel serum, that's fine, but just don't pick something that's oil based. In the same vein, don't put emollients on your face, moisturizers or sunscreens before you do your red light therapy.
Bev, this was incredible. I have learned so much from you once again. So to wrap this up, evidence supports that red and infrared light have different effects on collagen production, but both of them have anti-aging effects, correct?
That's correct, yes.
We also know that we can do too much of a good thing, and sometimes less is more, less is better.
Yes, just to be aware of the biphasic dose response and not to overdo your treatment, not to overdo the dose or the length of treatment, but just to stick to the manufacturer's recommendations.
Evidence also suggests that combining red light therapy with antioxidants offers a combination therapy which improves anti-aging and skin rejuvenation.
Yes.
And lastly, we know that cosmetics are formulated to give enhanced performance and superior antioxidant potential, correct?
Correct, yes.
Did I forget anything?
I think you got it covered.
Awesome. I have learned so much from you again, Bev, and I think my viewers have as well. Thank you so much for being here.
Thank you so much for having me. Love working with you, Claudia.
Likewise. And of course, you know that I love your serum and I can't wait for your other products to come out.
Thank you so much. Thank you.
Thank you so much for being here. Thank you, everybody, for watching. Bye.
Yeah. Oh, rubbish. I generally eat, sleep, breathe this stuff. I love it. Really do.
That's
you dare put that in the system.
I won't.
I won't sign it off.
Okay, I won't put that one in. All right, let's stop laughing all that. Oh,
Isn't it?
wow, you're on fire now.
You know what?
Yeah.
Maybe